So ignorance of science and its dynamics. Here's the aim of my talk. The aim is this, to give a detailed taxonomy of kinds of ignorance. I think it's not enough to make distinctions, even if the distinctions are all wonderful, because they have a set of distinctions, but you have no clarity. What you need is a taxonomy, and the difference between taxonomy and a set of distinctions will become clear if you're not aware of it. Then, to demonstrate with a case study that the scientific field moves through different kinds of ignorance until ignorance is temporarily removed, and the temporarily is also important. So I want to demonstrate that. And then I will abstract from this case, it's a case study, a tentative sketch of a general ignorance dynamics in science, and then we will touch many of the topics that were talked about already by Stuart and by others. So this is just a classificatory remark. This task belongs to the philosophy of science section of agnotology. There are many other sections in agnotology. This belongs to the philosophy of science and not the other, which we'll touch probably in the course of this conference. Okay, so here's the outline. I start with a taxonomy of kinds of ignorance, and then I speak about infectious diseases today, because that will be my case study. It's a very important, I think a wonderful case study that I use in many different contexts. I've been using it for the last 10 years, but I sometimes find something new, but you don't know the earlier talk, so you will be surprised. And then I speak about the history of the infectious diseases, and then from this history, then I can abstract a tentative sketch of ignorance dynamics in science, okay? And very traditionally, I start with a conclusion at the end. I always do that mostly, okay? Okay, so I start with a taxonomy of kinds of ignorance, and I make a terminological note first. Obviously, ignorance is the absence of knowledge. And what kind of knowledge, what concept of knowledge you are using here is a different story, and you can't use that from epistemology as justified true belief, because then in science we almost never have, in mathematics we do have, but in the sciences we have never certified a true belief, so science does not produce knowledge, it's a constant state of ignorance. That doesn't make sense, so you have to have something like confirmed scientific belief of the best kind, and that's how scientists then also speak about knowledge loosely. Epistemology is for that reason useless for philosophy of science. Okay, so, and ignorance is of course to be understood here without any pejorative connotation, it's just the absence of knowledge, period. Yes, in epistemology, knowledge is usually understood as justified true belief, and ignorance here in the philosophy of science context be understood as the absence of justified true beliefs? No, this would make sense if science regularly produced justified true belief, and it doesn't. At least we don't have proof for that or any very good argument for that. How not even the staunchest realists claim that today. If you look in philosophy of science, they say yes, it's approximate truth and blah blah. Whether they know what they're talking about is a different question. All right. So this is the first. With an understanding of knowledge as justified true belief, science would be in a permanent state of ignorance, and then all the dynamics is completely irrelevant because it's ignorant all the time. So that doesn't make sense. One should rather understand scientific knowledge as something like well-established scientific belief. And this is how most reflective scientists also speak about it, at least in physics, in other areas. So in biology, some biologists really believe we have the truth, evolutionary theory, and physicists are much more self-critical there due to their painful history of the last 120 years. Okay. So then we have an informative contrast between presence or absence of scientific knowledge in that sense, and then we can discuss meaningfully about that. So for instance, to illustrate, most cosmologists claim that they know that dark matter exists, but we are ignorant about its nature. And that's exactly that sort of knowledge and absence of knowledge, and in that particular case, of course, it's conscious ignorance about the nature of dark matter. But you find that in Nature papers, and so that we know that dark matter exists, period. Although there are dissidents, but that's not my topic today. And I shall develop a taxonomy of different kinds of ignorance by a series of 5 distinctions that is very scholastic and pedantic. I can't avoid it, but I try to help you by graphics to keep them in mind what I'm doing. So the first distinction is a very important distinction between conscious versus opaque ignorance. And that's the following. Conscious ignorance is what we know we don't know. That's where we know that there is ignorance, and that can be, of course, articulated by the ignorant person herself in the form of a question whose answer is unknown to her. Right? So I use this contrast between questions and answers, which is very, very useful in the discussion of ignorance. It's not mainstream, but I'm using it, and I'll try to persuade you that this is a very productive way of dealing with it. So, for instance, here's an example. What is the nature of dark matter? We can articulate the question, and we know that we don't know the answer, though this is a typical example of conscious ignorance. Opaque ignorance is what we don't know, we don't know. Right? We mentioned that already, I think, even yesterday and today. It cannot be articulated by the ignorant person. For instance, by a question. The person cannot ask the question because she's ignorant about her ignorance. And it was made famous by the hobby agnotologist, was mentioned already, Donald Rumsfeld, who died in 1921 with respect to the Iraq War. But he is the most influential hobby agnotologist of recent times, last 500 years or so. Donald Rumsfeld. Yes. Okay. So this is the first distinction. Now comes the second distinction, and that's a distinction among kinds of opaque ignorance, namely superficially versus deeply opaque ignorance. It's also a very important distinction, we will see. So this difference results from different causes of the opaque ignorance, possibly different causes why you are opaquely ignorant, and these differences play a role here. So superficially opaque ignorance, the question making the ignorance obvious can be immediately understood by the ignorant person if articulated by someone else. So the person cannot articulate it herself, otherwise she would be consciously ignorant, but if someone else articulates it, then the person is, in the case of superficially opaque ignorance, able to understand it immediately. Here's an example. Someone is not aware that she doesn't know what the capital of Australia is. She never thought of it, But when someone asks her what's the capital of Australia, she'll say, "Ooh, wow, I have never thought about it." Another example would be someone not knowing what the capital of Switzerland is. I mean, I cannot imagine that someone wouldn't know that. But sometimes there are people who just don't know, right? They may be consciously ignorant, but only when they travel. To say, "Daniel, I never thought of it. What's the capital of Switzerland?" Would you agree to something like that, Stuart?
Absolutely.
Yeah, absolutely. Yeah. Okay.
Shocked that I was ignorant of it.
Yeah. Okay. So the opaqueness of superficially opaque ignorance can be easily removed by asking the respective question. That's the point. And easily removed is, of course, a complicated concept, but empirically it's so. If you ask someone the question and say, "Whoops, I didn't know that," but she understands the question, then it was superficially opaque ignorance. That, of course, invites to many questions what is going on there, but would be a different talk here. So easily removed, the question can be immediately understood by the ignorant person. That is, the question does not involve unknown concept or a conflict with possibly unconscious presuppositions. That's the first way how to explicate that. Under which circumstances can something be easily understood? And one of the negative ways to characterize is that not unknown concepts are involved or anything, or prejudices of your side of presuppositions, and we come to examples where that does play a role. So that's the easily removed. This is largely, phenomenological. You can say that, we can find it, but whether we really understand it's a different question. Now, deeply opaque ignorance, by contrast, is the question making the ignorance obvious cannot be immediately understood by the ignorant person. And there may be different factors be involved. This may have various reasons to which I come later. So, the taxonomy where we are so far is ignorance there is first conscious versus opaque, and then we have two cases of opaque, superficially opaque versus deeply opaque. And now we continue with further distinctions, but they must be, in that taxonomy, otherwise you just have a series of distinctions and you never know where you are and what can be applied to what and combined with what. You can only understand that when you have a taxonomy. So the third distinction is now, there are two kinds of superficially opaque ignorance. Also, this was a topic already in the talks today, in some sense, but not, in this nice schema. Superficially ignorance due to the unawareness of misinformation. right? You are ignorant then because you are not aware that you're falsely informed by something. So, for instance, Ursula believes that there are 6 planets. So she is opaquely ignorant of the right number of planets. She doesn't know that she is wrong. So she's ignorant. If you say, does she know the correct number of planets? The answer is no. So it's the absence of knowledge due to misinformation. So it's a clear case of ignorance. I think there's no unclarity that this is a case of ignorance, false information. So the correction would be tell her of Uranus and Neptune, and then she corrects her superficially opaque ignorance, because then she sees, oops, I was falsely informed, and now I've got the right information, and I'm not ignorant anymore. Now, there is the other kind of superficially opaque ignorance due to unawareness of the missing knowledge that can be easily supplemented. It's a different case than having false beliefs, and there you have no beliefs, but it can be easily supplemented. So, for instance, Ursula is unaware that besides the Milky Way there are other galaxies, and she never considered the question. So she's ignorant about it, but it's superficial, because the missing knowledge can be easily supplemented by just telling her, look, there's not only the Milky Way, there are other galaxies as well. And then she says, oh, I didn't know that. And then, did you know that you didn't know? No, I was completely unaware. So this is the second kind of the superficially opaque ignorance cases, which are less interesting for the following, for science dynamics, but I need that for, so to speak, completeness of this scheme that I'm presenting. So here's the fourth distinction, and that's similar to the third one, but only concerning now the 2 kinds of deeply opaque ignorance. And deeply opaque ignorance is, generally speaking, that the existing background concepts, beliefs, and presuppositions make it impossible to realize that one is ignorant. So it's something in your head already, in your mindset, in your cognitive structure, how do you describe that, such that you are unable to realize that you are ignorant of something, right? So how can that be? Here's an example. Aristotle was ignorant about Galileo's law of free fall. He was completely ignorant about it, and if you tried to explain to him, he would have had a real problem, because the concept of a natural law didn't exist in antiquity. It was just absent. It's really an invention of the 17th century, and the way order was conceptualized in antiquity was just different, was by essential qualities, and we went away then in the 17th century from essential qualities, and instead of one-place relations, we take n-place relations, and the scientific law is a relation between things, a general relation, and that's a law, a general law, and Aristotle was ignorant of that. And then if you talked about the law of free fall, Aristotle would say, I don't know what you're talking about, right? And he would teach him, this deep change from how is order conceptualized from the way in antiquity and then to the modern way from the 17th century on. So that's a case where he's deeply opaque, ignorant, but it's very difficult to tell him about it. It takes weeks, probably, even an intelligent guy like Aristotle. All right. So to transform deeply opaque ignorance into conscious ignorance, background concepts, beliefs, and presuppositions, may not be even fully conscious, must be suspended. So for Aristotle, there was no alternative to conceptualize order in nature only by essential qualities. He did not think, I choose the possibility essential qualities and I don't like the other alternatives. That was without alternatives for that. So as for us, today, most people, not all, scientists think there's no alternative to thinking the order of nature in terms of natural laws. So for most scientists, when someone would say, wait a minute, are you so sure that natural laws exist? Yes, of course, this is what natural science is all about. But that's a historically contingent, anyway, and it was different at that time. All right. So, like in the case of superficially opaque ignorance, there are 2 kinds of deeply opaque ignorance. Right? And this is now important. So, the first kind is deeply opaque ignorance due to unawareness of the falsity of beliefs or suppositions. So it's falsity versus non-existing knowledge. Here it's falsity, and here, for instance, Aristotle ignorance about the evolution of biological species. He thought, and by the way, in a very empirical way, so forget about what the cliches about Aristotle, he was an empiricist, And he didn't just, dogmatically anything. So he said, he asked the question, are species immutable or are they not? And what did he do? He looked into the Egyptian sources, which were 2,000 years before him, and then he saw the depiction of species, and there were same cats that he was familiar with. So he said, no, species are immutable, and that fitted, of course, then with his metaphysical ideas. But he was ignorant, of course, about the evolution of species because he believed something falsely, right? And if you were to try to explain to him, look, Aristotle, you're wrong here, it would have been very difficult because he then believed that species are essential, these essential kinds, and these essential kinds are immutable, right? So it would have been very difficult to convince him, and also, I mean, if you look at the historical development, it was very difficult that we reached our state now to believe in biological evolution, right? So that's a false belief that he had, and it was so anchored in other presuppositions and concepts that it would have been very difficult, and therefore it's deeply opaque ignorance due to the unawareness of the falsities of some belief. And then there is deeply opaque ignorance due to unawareness of missing knowledge, right? And this is the following here, Aristotle's ignorance about black holes. I mean, you may have read some of the publications of Aristotle, but you never stumbled upon the concept of black holes, which is possibly not really surprising. But he was absolutely unaware of it. And to explain to him what black holes are is really, you need to teach him, laws, general relativity, well, the mathematics he didn't have. So it would be extremely difficult. And he was completely unaware of that a piece of massive ignorance from our point of view today. So that is deeply opaque ignorance due to unawareness of missing knowledge, but it's not easy to supplement that knowledge because it's in opposition to what he believed otherwise. And therefore this is a case here of deeply opaque ignorance. And clearly these kinds of ignorance cannot be removed by simply providing the relevant information. That is the point of this deeply opaque ignorance, and that is, of course, that is emerging in the history of science again and again, and you'll see later the examples. And then the ignorant person must first create the necessary conceptual space. Okay, this is metaphorical, but I think it's understandable. It must create the necessary conceptual space to accommodate this information by giving up the blocking beliefs or presuppositions. And that is a very, very painful and long process, usually similar to psychoanalysis. I mean, to get there, what is blocking is extremely painful and long and complicated emotionally and cognitively and all of that. So this is part of this deeply opaque ignorance. But this is not the end of difficult forms of ignorance, because there's another form, and that's a special case of radically deeply opaque ignorance that's even more radical. And this is, I haven't found in the literature at all, because you only get that with that question-answer approach. Radical, deeply opaque ignorance, not even the question that brings to light the ignorance is intelligible by the ignorant person, let alone the answer. So not even the question is understandable, and that's very important. Then you are really in front of a brick wall. And you don't even understand. It shows you should learn something and understand something new. And here is, first of all, an example of not radical, deeply opaque ignorance. Ask Aristotle what the nature of light is. He does understand that question, and he has an answer about the nature of light, but from our today's perspective, it's radically wrong, right? And it takes ages to convince Aristotle that this is wrong and what the right answer is in terms of, say, classical electrodynamics. So he's absolutely right. It's not radical, it's deeply opaque ignorant, but it's not that radical. So here's an example. So Aristotle understands the question about the nature of light. He's asked the same question himself, but he's ignorant about the correct answer, electromagnetic waves. But here's an example of a radically, deeply opaque ignorance. Ask Aristotle what the composition of water is. Aristotle wouldn't understand the question what the composition, because water is an element. He wouldn't say, what are you talking about? I don't understand when you ask him what is the composition, because you presuppose water is a compound and not an element, and say, what are you asking? I don't understand your question. It's an element, there is no composition. So the question is wrongly asked, And that's, of course, a kind of ignorance that's even more complicated to remove, and therefore it's this, what I call it, the radical, deeply opaque ignorance. And that is also important in the history of science. I mean, this is already what I'm telling you here, of course, part of the history of science, because Aristotle belongs there, quite clearly. Aristotle does not understand the question, because for him water is an element, so the question does not make sense. So, this is now the taxonomy of kinds of ignorance, and of course you find most of the stuff that has been brought up both by Stuart and by Nadit today, you find that here, but you find it in a more, as I think, more orderly fashion. So we have ignorance, then we have the first fundamental distinction between conscious and opaque, that will also play a role later. And then we have, in the opaque case, superficially opaque versus deeply opaque. Superficially easily removable, deeply opaque not easily removable, and then superficially due to misinformation or due to unawareness of an accessible question. Again, you see here that the question-answer approach is very fruitful, because you can articulate things you cannot articulate otherwise, or at least not as easy. Then in the case of deeply opaque ignorance, you have in parallel, you have, like here, the misinformation, unawareness. You have that here as well, unawareness of the falsity or unawareness of missing knowledge. But as I said, the deep case. And then you have, for deeply opaque, you have this next distinction, namely between radical deeply opaque ignorance and non-radically deep ignorance. And the radically deep is where you do not even understand the question, which would bring to light the ignorance. So this is now the schema, and I think all the other things that we heard today about first order, second order, and what not has a place in there. I have not systematically compared all the other classifications and distinctions, but it seems to me that this is a very useful one, and I try to show that and demonstrate that when we come to the case study that I'm discussing next. Okay, is that more or less understood and clear enough? All right. So, now this was static. And now we're adding dynamics. So you may see that my background is a physicist, so this is, I mean, how we do it, don't we? So, for a static taxonomy of different kinds of ignorance, a scientific development, however, is often a motion through different kinds of ignorance. So if you focus on one particular scientific specialty and you look how it's developing, then you see it moves through different kinds of ignorance, removal of ignorance, new ignorance into different kinds. And I think it's informative to do that, and I do that first. I give you an example, and then I abstract a tentative idea. Starting point at any stage of science, it's always conscious ignorance, and the attempt to replace it, it's knowledge. That Stuart says that in many publications. In a sense, it's also trivial. I mean, Popper says it starts with a problem. Of course, if you don't ask a question, of course, you don't improve usually the knowledge. So that is fairly clear, and it's always conscious ignorance. You know that you don't know, but you want to know, and then you ask the question, you understand the question yourself, but you're simply missing the answer. Okay, so that is more or less trivial. And I shall illustrate this march through different kinds of ignorance by an example from the history of medicine, the investigation of infectious diseases. This is a wonderful example where I can learn many things, and as I said, I'm using it in many different contexts. It's especially in the agnotology context. It's wonderful because you can understand it. If you look at the history of general relativity, it's much more complicated to explain to lay people. So I shall first give a sketch of today's knowledge of infectious diseases, because you may not be completely up to date, and then show how that knowledge replaced different kinds of ignorance in the course of history. So I'll first give you the picture, very, very, very rough, of today, as far as I need it then later for this dynamical story that I'm telling you. So infectious diseases today. So infectious diseases have been a companion of humanity all along, and also, of course, by many, if not all, other organisms as well. So this is just a part of evolution, that we are in competition, and then other species try to take advantage of other species. And they are caused by infectious agents called pathogens, and there are different kinds: bacteria, viruses, fungi, parasites, and prions. If you don't know what prions is, I'm going to explain it. That invade the body in one way or another, and then they multiply within the infected body. That's the idea of infectious diseases. The infectious agent is capable of replication in the host organism, but the replication mechanisms differ widely. really, and I'm coming back to that. Okay, so that's that picture. Very often, infectious diseases are spread from person to person. This is, you may remember, we used to have for 2 years or 2.5 years now, 40 years, a sort of disease, you know, it was called pandemia, you may remember it. Anyway, so this was, of course, a virus, of course. All right, so here are examples. So for bacteria, tuberculosis and plague are bacteria-caused diseases, then viruses, COVID-19, then HIV/AIDS, foot and mouth disease, a virus-caused, then fungi make candidiasis, it's a sting. Parasites make malaria and worms. In prions, Creutzfeldt-Jakob disease, mad cow disease, BSE. I mean, 30 years ago, this was almost 30 years ago, this was a really big thing. With the prions, and Creutzfeldt-Jakob disease is for human beings. It's a nerve disease that leads to dementia, and that mad cow disease is very important also economically. Okay, these are the different pathogens. They cause different diseases. And the history now is, I can of course only present a few glimpses with an emphasis on ignorance. So I'm giving you a sketch of that. You won't learn the complete medical history there, but I'm selecting those events and developments that are important with respect to the ignorance dynamic. So this is in a sense, you know, historical judgment is always selective, and I'm telling you what my selection criteria are. All right. So until the mid-19th century, the supposed cause of many infectious diseases, especially plague, was miasma, bad air, and that's still, by the way, present in the name malaria. Malaria is nothing but bad air. So for the Italians, that's no problem. For those who know Greek, of course, also. Oh, I'm sorry, Latin, but Greek, I don't know. No, Latin, okay. And emanating from rotting organic material. So this was a theory, and that it comes from antiquity, and it's called the miasma theory. Miasma, the bad air, and that was causing that was the idea that was causing the diseases. And the miasma theory was developed already in the 4th century before Christ by Hippocrates, and was continued by Galen in the 2nd century, but it was also popular, which was unknown to me, also in China and India. I don't know exactly what the process was, whether this was diffusion of knowledge or whether they independently developed that. I think diffusion was also part of the story. It's interesting by itself. But anyway, this is the prehistory of what I'm going to talk about anyway. So this was the miasma theory, so that was well established, right, over 2 millennia. So that was very stable in the mind of people, okay? And there was deeply opaque ignorance about the real causes of infectious disease. They had it all wrong, right? Very, very deeply wrong. And it was very hard that people even learned how wrong they were. So, from the mid-19th century on, clinical medicine became a scientific discipline. The history of medicine is really interesting because until the mid-19th century, the Western tradition of medicine was really, for most of the patients, much worse. So the doctors really produced much more harm than any good for the patients. So this is a very sobering history of the Western tradition. If we look at the medical tradition of Western culture, it's a catastrophe. And nobody seemed, at least seriously realizing it, that for more than 2 millennia, it was really the doctors, the medicine doctors, who were doing more harm than good for the patients. This is, seems to be really a fact, which is very sobering if you think about enlightenment and blah, 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 and rationality. So if you look at that part of the tradition, not physics, but at that part of the tradition, my God, this is not funny. Okay, so by the 1870s, miasma theory was supplanted by the germ theory of infectious diseases, especially due to the work of Louis Pasteur and Robert Koch. And germs was one of the terms that was used there, germs, but also other terms. If you read the original sources, be very careful. There are many different terms. Also the term virus is used there, right? And it is not specific at that time, but it was just germs. They said, yeah, there is something living. Therefore, microbiology is the very small organisms. So germs are living microorganisms made visible by microscope, and the prototype is bacteria. So that was this immense discovery there by these giants there in France, in Paris and in Berlin, and there were deep enemies, but for us today we can say, my God, we've got to be grateful to these because from then on also the medical contribution to the improvement of our physical life was strong. Before it was more hygiene. So don't overestimate the influence of medicine. It's really hygiene that made the bigger contribution. By the end of the 19th century, bacteriology was a well-established scientific discipline with sub-discipline, everything that belongs to a scientific discipline, journals, professorships, institutes, blah, 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 conferences. That was well-established by the end of 19th century. And I would have loved to live between 1870 and 1900 in bacteriology because, you know, every other year you have discovery of a new bacterium and then you could identify it and, you know, and you could treat it possibly. So it was wonderful. Must have been scientifically a time of paradise, right? So, and if you describe that now in terms of agnotology, of ignorance, that removed the deeply opaque ignorance due to the falsity of miasma theory. So that's the kind of ignorance that was dominating here. But it created new deeply opaque ignorance by the belief that all infectious diseases are caused by microorganisms. So that was a new creation, you know, a new kind of ignorance that was created by this enormously successful theory, because that everyone said, well, all infectious diseases are caused by microorganisms. And that then led to the next story. There was a deeply opaque ignorance about other kinds of infectious agents. People didn't realize that. They were simply, well, that slowly transformed into conscious ignorance, namely about viruses, leaving other pockets of deeply opaque ignorance about prions. I'm coming back to that. So that's an interesting process here. Slowly people realized at the turn of the century there are some diseases and we can't find the bacteria. By no means, and also some of the properties of these diseases were strange, but it took them more, well, I'm probably saying that here, that was begin of this transformation with anomalies. That's a term by Thomas Kuhn. And this, I'm coming back to this term anomalies, because this is where Stewart uses the term failure. And the term failure doesn't allow for an important distinction that the term anomaly allows and failure doesn't allow. So he would probably, Stewart would describe that as failure. I describe it as anomalies. And there was the anomaly that, against your expectations, you couldn't understand these diseases. You couldn't identify the infectious agents. So at the end of the 19th century, there was the discovery of some infectious diseases with very puzzling characteristics. And for instance, in many aspects, the behavior like bacteria-caused diseases, they were very similar, those that we today know were caused by viruses, in many aspects very like bacteria, but in aspects very different, very, very different, and really disturbingly different, namely the invisibility of the infectious agents in the microscope. And before you could all then, by staining techniques, you could identify the infectious agents in the microscope, but you couldn't do that. Then there were resistance to alcohol, which is absolutely crazy, right? You have something that is not a bacteria, but it's resistant to alcohol, but it can still replicate, you know? How is that possible? Something organic can replicate. Or not growable in artificial culture, which was one of the litmus tests for bacteria. You grow it in the culture, then you can investigate it, and look what it's doing, and then you find it in the microscope and you can stain it and blah, 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 all that. So this was very strange. It was an anomaly, and people said, this is very strange with these diseases. And the two main examples, tobacco mosaic disease and foot and mouth disease, and they are also very important economically. So there was a very strong outside pressure on medicine, because Hungary was dependent, I think, in its economy on tobacco planting, and the tobacco mosaic disease really destroyed then large parts of the tobacco. Foot and mouth disease became later very important, and millions of cattle were killed then in England later at an outbreak of foot and mouth disease. So these are not just, academic playgrounds, so this is really important. And it took more than 50 years, well, roughly 50 years, only in the 1950s it was fully understood that these diseases were caused by viruses. It really took 50 years because the ignorance about them, and that's a special topic for our own talk, one can analyze what the kind of ignorance was, or the source of the opaqueness of the ignorance, why it took so long to understand what the viruses were. The fundamental barrier, now to make it short and concise, the fundamental barrier making ignorance about viruses deeply opaque, the apparently logical dichotomy between alive and dead. There is just no conceptual space for viruses if you have that dichotomy, that either it is alive or it is dead. And I remember discussions still in the 1970s, where people then were discussing whether viruses are alive or dead. Wrong question, but put upon you by your presuppositions. And you think it's logical, so there's no way to avoid that, and it turned out that it's wrong. It's the wrong dichotomy. So, viruses become only alive, in scare quotes, only when they're inside their host. And that is a concept, of course. Aliveness is not something that's context dependent. What you think, I mean, either a cat is dead or it's not dead, but the virus is such an animal that it's, well, animal, of course, in scare quotes again, it's alive only when inside their host, and that made the dichotomy between alive and dead, made it obsolete, and then you created the conceptual space, right? This is the metaphor I'm using, that sometimes you must create a conceptual space such that you are able to think something or imagine something, and that was necessary here. So from the 1950s on, the idea was that all infectious diseases were believed to be caused by DNA or RNA containing infectious agents. That was done at the mid-50s sometimes. So the discovery of DNA structure played a role, and empirical stuff, and electron microscopy, and all that stuff in order to get to this picture. And then at the mid-50s, there was rather stable idea what infectious diseases are. And that was both empirically and theoretically extremely well-founded. So people were really deeply, deeply convinced that this is the truth about infectious diseases. There, the infectious agents contain either DNA or RNA. Okay? However, there was deeply opaque ignorance about the existence of infectious agents with alternative replication mechanisms such as prions. And people couldn't dream of them because they thought an infectious agent must be able to replicate within the body. What are possible replication mechanisms? People had in the 40s thought that the genetic material was made of proteins, and then only very reluctantly realized, no, it's DNA, because DNA was thought to be a very stupid molecule, and you need a complex molecule that's possibly also somehow intelligent. So proteins were out of the picture completely for evolution. They can't replicate. Only DNA and RNA can replicate, and therefore people were really deeply ignorant about the possibility of others, and prions are just proteins that are able to replicate. There was even radically deep, opaque ignorance about the replication mechanism of prions. That was just completely unimaginable. Right? The relevant diseases which are caused by prions are all brain diseases, interestingly. And for example, it was crapy in sheep. That was already discovered in the 18th century. Right? But it was not very relevant. We had a few cases, cases in England. It was discovered already then. Then the Creutzfeldt-Jakob disease, discovered in the 1920s. And then BSE, or mad cow disease, discovered only in the 1980s. And that became highly relevant because it really influenced the meat industry to a very, very deep degree. How much time do I still have left? 2 hours, right? What is it? Okay, 2.5. Yes. Right, okay, great. So, and there were, again, like in the case of the discovery of viruses, very parallel. It was that these diseases had very surprising properties. There is, for instance, absolutely no immune reaction of the host after infection, which you do have in virus and bacteria-caused diseases. And the infectious agent is much more resistant than viruses. And that was, of course, then practically highly relevant. So sterilization 15 minutes at 100 degrees is not enough. You need half an hour at 120 degrees, and pressure, blah, blah, blah. So this was also for practice extremely relevant, and that was really in the 80s was those of us who remember that and did not catch Creutzfeldt-Jakob, because then you wouldn't remember today. So we remember that there was quite something going on there. And then came this revolutionary hypothesis by Stanley Prusiner in 1982. The infectious agent does neither contain DNA nor RNA. It's instead a falsely folded protein. And these proteins that are able to this configuration, the false configuration, were baptized prions by him. And of course, Prusiner was vehemently rejected by the scientific communities. And the replication mechanism in the host is now, this is a phenomenological description, it's not the full truth, it's not yet, as far as I know, really fully known. The replication mechanism is, roughly speaking, the falsely folded proteins somehow catalyze normal proteins of the same kind to change the configuration. So the falsely folded infect the correctly folded, and they become falsely folded, and then they coalesce in the brain, and then we get the brain disease. So that's roughly how that works precisely. This is a very superficial description to describe it as a catalyst, but that's a way to understand how or at least superficially understand how that mechanism works. So first, Prusiner was vehemently rejected by some even after him receiving the Nobel in 1997. There was still a publication that said, this is premature, we must continue the search for DNA and RNA, it's impossible, that the proteins multiply in there, and so on and so forth. So this is really interesting. You see the resistance. The resistance was enormous, and it was well-founded. It was not dogmatism by the scientists. It was extremely well-argued and well-founded. That's the problem in science, that sometimes we have got so good theories which turn out to be false, and then you can't believe that they are false. Right. So, and now I give you a tentative sketch of ignorance dynamics in science, abstracting that from that one case. Well, in physics, many people in philosophy think, if you do inductive inference, you need many cases and many different circumstances and blah, blah, blah. And in physics, it's different. A good induction in physics needs 0 or 1 case. Right? This is the normal thing in physics. So 0 means you make a thought experiment and then you generalize, or you have 1 case. So I'm behaving very similar here. And what I'm building here, this ignorance dynamics, is built from both from Thomas Kuhn's phase model of scientific development and then from elements of a theory which you are completely unaware of. You are completely opaquely ignorant, but there's a wonderful philosophy of science called systematicity theory. It's been published, Systematicity in Nature of Science. You've been ignorant since 2013, and even before you were ignorant, because, well, it didn't exist, but you're still ignorant. Okay. Anyway, so it's several phases that I'm using here. And it starts with the inception of a scientific field, and that is based on some familiarity with the subject matter, together with conscious ignorance. So when you ask, how did astronomy develop, and then of course people knew the phenomenon, and they say, oops, but I don't understand about the rhythm of the eclipses, and stuff like that, or you start in biology, and you say, oops, there are so many organisms, can you classify them, and so on. So you always start with some familiarity, and then you try to systematize that because you have conscious ignorance. And for instance, here in the example of the infectious diseases, the miasma theory does not really explain, and then you have physiological discoveries that led to the conscious ignorance that you say, wait a minute, that miasma theory is not really the explanation for infectious diseases, so we do not know the cause of infectious diseases, and that is then the start of that bacteriology or theory of infectious diseases. Then you do have these questions and a background of familiarity, so you have some knowledge, or at least roughly knowledge, or hypotheses, plus conscious ignorance, and then you can pursue your conscious ignorance, which you can articulate in forms of questions. Right? There you come in why I think the question-answer dynamic is so important for ignorance, because then you can describe what's happening in science, because scientists ask questions, right? And the basis of the question is the ignorance, the conscious ignorance, and you articulate that in a question. So you do research on the pertinent questions, and you are increasing the overall systematicity of the field. That is how systematicity theory describes the dynamics, and that results then in some scientific knowledge. Then you know something, you know more than before. It's more systematic, for instance, by introducing classifications, primarily causal relations, and so on. And the example here is from the case study, the discovery of a multitude of diseases, of a multitude of disease-causing bacteria. Then you could say, okay, now we have a classification, this bacterium causes this and that disease under those circumstances, and then you have scientific knowledge because you asked the right question. You asked a question about this area with which you were familiar, namely people knew that there are infectious diseases. All right. Then the next step is that some questions remain open. And then you have conscious ignorance, leading to expected discoveries. And that's very important. Kuhn makes this distinction between expected discoveries and unexpected discoveries. That's a very important distinction for science. So the example here is, what is the example, say, in 1880 or 1890? What's the yet unknown bacterium causing disease X? You know, according to the theory, there must be a bacterium, but you don't know what it is. You have characterized it, so you know what you're looking for. And once you found it, it's an expected discovery. So Kuhn describes it once that in a very nice way, and a successful expected discovery is not the reason for surprise, but the reason for gratulation, right? Because you know what you were looking for, and then one clever team in one lab is able to make the discovery, but the discovery is completely expected. The only question is who can do it, right? So, all right. But, so we have this situation, we have conscious ignorance, but there are hidden imperfections of the acquired knowledge, like gaps, overgeneralization, inappropriate conceptualization, etc., that may in addition produce superficially opaque ignorance. So when we say that there's some scientific insight produces new questions, I come back to that, that's very superficial. It must be much more careful. So there is conscious ignorance that is produced, but there is also superficially opaque ignorance produced. So for example, the form of bacteria colonies on culture medium is informative. People didn't realize that, but I didn't know it either by just reading the literature. Okay, so, but it was superficially open when I open ignorance. So when you ask, did you consider that this bacteria made this or that form of the colony on the culture? There's information in that. You should investigate that. Then people say, oh, good idea. Yes, sure. Yeah, right. So it was superficially opaque. By asking the question, people would immediately realize, yes, that's a good question. Okay, let's investigate. But also, in addition, there is deeply opaque ignorance produced. So in our examples, infectious agents of some diseases can in principle not be grown on culture media, viruses and other obligate parasites. So this is deeply opaque ignorance. People didn't realize that. They didn't know anything. This was a consequence of their discoveries in overgeneralization. They thought all infectious diseases are caused by bacteria, but they aren't, right? And they didn't realize that. Okay, then the next step is that hitting upon these imperfections may lead to different kinds of anomalies, namely with smooth traditions. And here comes the difference now to the terminology of failure. Namely, anomalies have two different kinds, and one kind is mere anomaly. Something does not work as expected, but no reason for concern about the underlying framework. Right? You have a problem and say this problem should be solvable, damn it, but you can't solve it. But the reaction is not, oh, the framework must be wrong. Right? But you say, no, we need more work, right? More money. So example, say the especially difficult discovery of a specific bacterium, which happened, and then people had anticipated it takes us 6 months to discover that bacterium, and then it turned out, no, it took you 3 years. So this is really, it's not a failure, right? Although, in a sense, it's a failure, it violated your expectation. But this is called a mere anomaly by contrast to severe anomalies. And that's the fundamental distinction here. Namely, severe anomalies, they cast doubt on the underlying framework and gradually transform deeply opaque ignorance into conscious ignorance. So that only works for the severe anomalies, and here's the example, the insight that some infectious diseases are not caused by bacteria. When people said, this is not a temporary failure, that we don't find the damn bacteria, but they say, there are no bacteria, there's something else and we have no idea what it is. So that brings doubt to the framework, namely the framework that all infectious diseases are caused by bacteria. And that's a fundamental difference between these kinds of anomalies. The mere anomalies, Lakatos once said that, or Fayad and Lakatos, I think, that science is in a constant ocean of anomalies. You can't expect when you are a scientist that everything, every problem you tackle will be solved in the first step. Then you say, now it's the solution. And then 2 weeks later you say, no, it's not a solution, a mistake, damn it, so let's try again. Right? So it happens again and again and again that nature shows you your expectations are wrong, right? And then to correct them, and it's a difference whether the correction is just saying, changing something very small, or whether you change the framework. Right? And changing the framework is the effect of severe anomalies. You can only say that in retrospect, by the way, and mere anomalies don't do that. And that's very important because these are all failures, right? But you can't make conceptually the difference here that's important with the terminology of failures. It's severe anomalies. Okay. Then comes number 5. The resolution of severe anomalies may lead to unexpected discoveries. They are unexpected because you didn't know what the reason of the failure was, and therefore it's unexpected when you discover something, and that leads then to, in Kuhnian terms, revolutionary scientific developments, implying severe revisions of the previously accepted scientific framework, for which you were unprepared because it worked fairly well, made successes, but then you realize, damn it, there are some cases, more or less isolated, but not completely, where you say, ooh, something must be wrong here, right? And the example is then the discovery and understanding of viruses. There you, and that took 50 years until you worked, from the severe anomaly until you had a positive theory then that there are viruses that do that job. And then the circle may begin anew because of hidden imperfections of the knowledge gained. This is what I said. And in this wonderful case of medicine, that's exactly the same then, the same story unfolding concerning the prions. And it's really very similar. I mean, all these anomalies that in 1900 concerning viruses were very similar than in the 1970s, when Scrapie especially was investigated and Kreutzfeldt-Jakob, and then people said, and then the same circle begins, and you see then this dynamics of these changing, sometimes simultaneously existing different kinds of ignorance. This dynamic model gives you that. So, yeah, this is what I said, this discovery of diseases that are not caused by DNA or RNA, but by prions. And that was so surprising because both empirically and theoretically, it was so utterly persuasive that it's DNA or RNA that must be contained in the infectious agent. Why? Empirically, almost all diseases, apart from 3, could be read in this way, so you could identify the viruses or the bacteria. And theoretically, there was no mechanism how the infectious agent could multiply in the host organism. Right? So it was absolute. So all you want to have, you have a good theory and you have all the data and all fits together, and you say that's the final word of infectious diseases. Wow, here comes the surprise. First is an anomaly that you didn't find. Kreuzinger tried to find the DNA in, I think he worked with Kreutzfeldt-Jakob, I don't remember. Anyway, it doesn't make a difference. And he didn't find it, until he decided, well, I can't find it because it's not there. It's a black part in a dark room that doesn't exist. It's in a dark room, a black part that doesn't exist. Okay. So here's my conclusion. It's often heard, and I also sometimes said it, that new scientific results produce new questions. Well, that's correct, but it's very superficial and it's very coarse, because the questions that are produced are connected with different kinds of ignorance, and it's fundamental to see that. So this is okay to say, but it's on the border of being deceptive. Because new results produce 3 kinds of question or ignorance, respectively. Namely, they produce conscious ignorance. For example, how far can the result be generalized? So you find a result and then you say, oh, that's interesting, but wait a minute, you've got to generalize it somewhere. How far can that go? And then if you're a normal scientist, you just realize that, well, that's a special case. Can it be generalized? So the kind of ignorance is conscious ignorance. And of course, you know what you do next. I mean, we had the same example today already with the lab. Such questions can be immediately asked. Then there is superficially opaque ignorance. So, for instance, by implications that are not obvious. So you get a result that has implications, but it takes a while until you discover that implications, and then you say, oh, wow, interesting, next project, right? We can pursue that. So the respective questions can only be asked after some period of scientific work with a new result, because then you realize what the implications are, and then you don't have to, they are not unsuperable obstacles, but it takes a while until you realize it, what all the consequences are that the new result has. But there's also deeply opaque ignorance, newly produced, well, not newly produced, in fact. The respective questions can only be asked when the new result and its implication confront their limits in the form of severe anomalies and have led to revolutionary ideas. So you have to wait, possibly, 50 years or 100 years, until you see, wait a minute, there is something fundamentally wrong with that. So if you take classical mechanics, It was accepted only 1740. It took 50 years in the beginning until Newton, well, Newton was dead by that time, and there came the French mathematicians and said, we don't care about your philosophical question, we just have to calculate, and this was wonderful, 170 years until the late 19th century, and then problems came up. They say, damn it, this classical framework, something is wrong. Someone said it's a wonderful blue sky, but two little clouds there on the horizon, and these little clouds then developed into a catastrophe for classical physics. So that may be a very, very long way, but this is also then deeply opaque ignorance, showing only later when new revolutionary ideas. So it seems, therefore, that an insight into ignorance dynamics deepens our understanding of processes of scientific development. I do not think, contrary to your picture yesterday, that due to science ignorance increases. This is false. The amount of ignorance can only decrease. Why? What changes is that opaque ignorance becomes conscious ignorance. That is so the realm of conscious ignorance becomes later. But Aristotle was ignorant about black holes, and nothing changes. So what we are absolutely ignorant about, or what we are ignorant about, stays ignorant until we remove it. The point is simply we don't know it. So what changes is our awareness of ignorance, and that grows. So the amount of the transformation of opaque ignorance into conscious ignorance, that changes. But it's not the amount of ignorance altogether, the absolute amount of it. That's false. So the picture, your picture there, with that circumference, that should be changed. It's really the transformation of the opaque ignorance into conscious ignorance. That's the process, what the process of science produces. Okay, thank you very much.